Welcome to the last breakfast. Please enjoy the video.
You start by confirming prerequisites: installed Nsight Compute and a compatible NVIDIA driver, plus a compiled CUDA binary. Once done, set CUDA visible devices to pick the GPU and run NVIDIA SMI to verify the device state. Then launch the profiler with Nsight Compute or the GUI, pointing to your executable and any necessary arguments. You do this to get a first lightweight collection, ensuring the tool can communicate with the GPU, and your app is accessible for deeper measurements. You now refine data collection. Choose metrics or sections tailored to your bottleneck, memory, compute, or occupancy, and invoke Nsight Compute with metrics or select sections in the GUI. Once you've identified hot kernels, use launch skip and launch count to focus on a single kernel invocation and apply collection rules to lower overhead. Make sure to compare runs with different flags and problem sizes. This helps separate measurement noise from real regressions and reveals whether memory bandwidth, registers, or warp divergence dominate. You finish by opening the report in the GUI to correlate source lines with kernel metrics, inspect timeline and source-correlated roofline views, and export CSV or HTML for side-by-side comparison. Once done, iterate. Change launch configuration, optimize memory access, or reduce register pressure and reprofile. If results seem incomplete, make sure debug symbols are present, increase sampling resolution, or switch from lightweight sampling to full profiling. This fixes missing counters and gives the
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.